Hello students, welcome back to the class. In the today's class we are going to discuss about the rectilinear propagation of light. So already in the last class we completed Fresnel half period zones as well as zone plates, its construction and also the theory. And in the today's class we are going to discuss about rectilinear propagation of light. So already we know many properties of the light. So out of that there is a one property called as a rectilinear propagation of light. So nothing but what it says that light always moves in a straight path. So this is the concept already we know. So for the same thing rectilinear propagation we are applying to the diffraction. So whatever we studied in the last class, that is the zone plate. So from the zone plate what we concluded is whatever the wavefront is there, from the wavefront if light is coming, then the wavefront must be divided into a Fresnel half period zones. It must be divided into a many number of zones so that the resultant effect at a point you are going to be have is effective. So this is what the concept we studied in the last class. Okay, so on the basis of the same thing we will go on studying the rectilinear propagation of light. According to the Fresnel, a wavefront must be divided into a many number of zones. So that's what this is the wavefront I am having. So let the wavefront, I'll take it as A, B, C and D. This is the wavefront. And now I already divided a wavefront like many number of circles here. M1, M2, M3, M4, Mn. We are making these circles, means we are going to divide a wavefront into a many number of circles called as zones, because we are going to get a resultant effect at a point P. This is the same thing when you will keep perpendicular to the paper, it will be looking like a figure B. So take it as a figure 1, and when we will keep a figure 1 perpendicular to the paper, then it will be exactly looking like a second image. Okay, so now as we want to find the resultant effect at a point O, we are dividing a wavefront into a many number of zones. Now in rectilinear propagation of light, what will happen? Suppose if you find the amplitude at a point 0, amplitude is nothing but a brightness. So you know some light will be dull and some light will be having more brightness. So the whatever the brightness is happening at a point O depends on what factors. So that brightness is called as amplitude. So according to Fresnel, we divided already into a many number of zones. So after dividing the resultant effect at a point O, what will be the resultant effect? So that's one we are calling it as amplitude. So here what is happening? The amplitude is mainly depends upon three things. So first thing, it is directly proportional to the area of the zone. So what they are saying, the resultant effect at a point O is directly proportional to the area of the zone. How much area your zone contains. So different zones we are having. M1 zone, M2 zone, M3 zone, M4 zone, up to Mn zone we are having. So how much area it contains, on that the amplitude it depends. This is the first thing they are telling. And the second thing is, it is inversely proportional to the, it is what? Inversely proportional to the distance of the point, O from the P. So whatever the distance is there, it is inversely proportional to the distance. Means what? If it is nearer to the point P, then the amplitude will be highest. Suppose the distance if goes on increases. So now see, suppose this is the first distance from P. So here distance is less, so the amplitude is more. But if you go for M1, the distance increases, so the amplitude decreases. M2, if you go again, the distance increases, the amplitude decreases. So like that, how the distance of the zone goes on increases from the point, the amplitude goes on decreases. Yeah, of course, because when we are nearer to the bulb, suppose any bulb is giving the light, suppose if you are nearer to the bulb, then maximum brightness we will get. How we will go away from the bulb, the light intensity goes on decreases there. So nothing but what? The amplitude we will say. That intensity is called as amplitude. So like that, how the distance goes on increases like this. The amplitude or the intensity at O goes on decreases. So that's what I said. It is inversely proportional to the distance. Okay. And the third thing, it varies with obliquity factor. It varies with what? Obliquity factor. So obliquity factor is nothing but the value of 1 plus cos theta. And theta is what? Here the angle. So see here, every time the angle goes on changing, isn't it? So how the angle changes? The cos theta value goes on changes, because when it is like this, the theta value is 0. So theta 0 means cos 0 is equal to 1. So 1 plus 1, 2. Obliquity factor becomes 2 there. But if the angle goes on increases, so at some point what will happen? It is equal to 90 degree also. So what is the value of cos 90? It is 0. So 1 plus 0 is 1. So like that, obliquity factor varies from 2 to 1. Means it decreases. So that's what it depends upon the what? Obliquity factor. What is obliquity factor? 1 plus cos theta value. Okay. So this is what I want to say. The amplitude at a point O. Amplitude is nothing but what? The intensity of a light at a point O. It varies with 3 factors. It varies with 3 factors. One is it is what? Directly proportional to the area of the zone. Area of a zone increases, then the intensity of course goes on increases. Okay. So second thing, it is inversely proportional to the distance. And third thing, it varies with the obliquity factor. And in the today's class, we are going to the first point, that is area of the zone. So we are going to calculate the area of the zone here and how it depends the amplitude. Okay. So see here, as we know already, the construction of the zone plate. Okay. So what is the construction of the zone plate? From P to O. Suppose the distance, I'll take it as A. Then by taking O and the radius is equal to A plus lambda by 2, we'll draw a circle on the wavefront. Okay. So this is radius. And what is the radius of the second circle? Yeah, A plus 2 lambda by 2. Like that, the last zone, the radius is A plus n lambda by 2. So this is what the thing we know. So see here, from P to O, the distance is A. From O to M1, the radius is A plus lambda by 2. Then, and we are finding the area. So see here, the whatever the area we want to find. So the zone is in which shape? It is in a circle shape. So that's what we should find, the area of a zone. Area of the zone value becomes what? Pi r square, because it is in a circular shape. Okay. So the formula is a pi r square. That's what we want to find the radius. We need a radius here from P to M1, isn't it? So what will be the radius of this? So if you know R value, then area of the zone directly you can calculate. So that's what I am concentrating on, PM1 value. So see here, this is A and this is A plus lambda by 2. Then from these two we can calculate the PM1 value by using the what? Pythagoras theorem. So apply the Pythagoras theorem here. So if you apply the Pythagoras theorem, then easily you can find here. So what is the Pythagoras theorem here? OM1 square is equal to OP square plus PM1 square. This is what the Pythagoras theorem. So from this we can find the PM1 square value. So what is the PM1 square value? Because we need a radius here. Okay. So PM1 square is equal to OM1 square minus OP square. So which is equal to, what is OM1 value? Yeah, A plus lambda by 2. So substitute here, A plus lambda by 2 whole square minus OP square. So OP means A. So A square. Now A plus B whole square formula we should apply here. So if you apply, what you will get the answer? A square plus b square plus 2ab. And again this minus a square as it is I'll keep. Only a plus b lambda, a plus b whole square formula applied. And now here you see a square minus a square get cancelled, and this two get cancelled, so a lambda is remaining. And here we cannot take a plus lambda square divided by 4 because lambda is the wavelength of the light, whatever light is coming, no, that wavelength, and already it is less value. And if square and divided by 4 if you make, again it will be very negligible value. So that's what here we will finish. Okay, so what we got the radius here, PM1 value, the radius is square root of a lambda and the square of the radius becomes a lambda. Okay, so this is what first zone radius we got. So that's what I'll take it as what r1 square is equal to a lambda. So from this we can write it as what r1 is equal to square root of a lambda also. Okay, so that's what is the area of the zone? Yeah, apply the formula. So area of the first zone calculate. So first zone means m1. This area we are finding. So area of the first zone, let it be taken it as a1. So a1 is equal to pi r1 square we can write. Pi r1 square, substitute the value. So a1 is equal to what is the r1 square value? A lambda. So if you substitute, what you will get? Pi a lambda. So this is the area of the first zone. Okay, simple calculation is there. And next what we are making, the area of the nth zone I'll find because I want to know how the area is going to change. Okay, so that's what see, area of the nth zone means this is, so here this whole circle radius means from P to M1, and here we should subtract the n minus 1th, then only we can get only this much area. Only the shaded part I needed. Understanding? This part I needed. We don't want the in between part. Okay, so that's what. First calculate the PM1 square value. So according to this, PM1 square is equal to a lambda you got. If suppose PM2 square was there, then 2 a lambda we would have get. So like that, what is the value of the PM1 square? Yeah, so here we will get this value as an lambda. We are getting the value is what? An lambda. And now in the same manner we can calculate the Pmn minus 1 whole square. So if you calculate that value, then what would be that equation? A into the bracket n minus 1 lambda, isn't it? So like that we are getting this thing. And now what area of the nth zone we needed, only this part is needed. Okay, so that's what I'll write here, area of the nth zone. We are going to calculate the area of the nth zone. Okay, so if it is the case, how we will get an value? So an value is equal to pi rn square minus pi rn minus square, because whole area minus this area we should make, then only this part we can calculate nth zone area. Okay, so substitute the value pi of, so already we know rn square value, so substitute here. What is the rn square value? An lambda minus pi, what is the rn minus 1 square value? Yeah, a into the bracket n minus 1 lambda. So simplify this one. So if we simplify, what we will get? A pi n lambda minus, so if you multiply it with the bracket, a n pi lambda and minus plus, what we will get? Yeah, pi a lambda we will get. Okay, so here a pi n lambda minus a n pi lambda get cancelled, plus and minus. So what is remaining? Pi a lambda is remaining. So like that, what we got? The area of the nth zone, that is an is equal to pi a lambda. Okay, so pi a lambda we got. Now if you see the derivation, then easily you can understand the area of the first zone value you got, a1 is equal to pi a lambda, And the area of the nth zone also you got an is equal to pi a lambda. So in between that, if you calculate the area of the second zone, understanding, the area of the second zone means m2 value, only m2 we needed. Area of the third zone means m3, understanding, only this part. So same procedure applying. If you go on calculating, no, every time you are getting the area of the zone will be same, that is pi a lambda only we will get. You can try this one also. After this, finishing this video, you can try a2 value, a3 value, like that. So if you try, then you will get the what, same quantities, which is nothing but pi a lambda. So from this, one thing we can conclude, that is, if you see the radius will be like this. R1 is equal to square root of a lambda, R2 is equal to square root of 2a lambda, up to, if you take Rn, it is square root of n a lambda. This is the radius. But if you take area, a1 is equal to pi a lambda, a2 is equal to pi a lambda. So like that up to an, if you calculate, no, it is a pi a lambda only you will get. Okay. So this is the main thing I want to say here. This is the main thing. So from this, what we concluded is the radius of the zone varies with the natural numbers. So the radius is proportional to square root of n, means natural numbers. First zone square root of 1, second zone square root of 2, third zone square root of 3, nth zone square root of n. Okay. But if you take a area, it will be constant every time. So that's what, it doesn't depend upon the square root of the natural number. So it is value is what, pi a lambda. Pi is a constant quantity, a is the distance of the p from point O, and lambda is the wavelength of the light used. So that's what, how the amplitude of depends upon the area of the zone I said. But here area, what we got a constant value. Okay. So this is the 50% derivation of the rectilinear propagation of light. Okay. So once again, see, in the rectilinear propagation of light, so rectilinear propagation of light is nothing but what, the light always moves in a straight path. So by taking last point, what we concluded, if you want to get the resultant effect at any point, then a wavefront must be divided into a many number of half period zones. Okay. So that's what we divided this ABCD wavefront into a many number of circles like M1, M2, M3, M4 up to Mn. So that the resultant effect at a point O we are getting. Now the question here, in the rectilinear propagation of light, what is the intensity at O? Intensity is called as what? Amplitude. So remember, always the intensity at a point O depends upon three things. What is those things? Intensity at a point O depends upon the area of the zone. Area means this circular zone area. So if area is more, the intensity is maximum. If the area of the zone is less, then the intensity is less. So this is the first thing. Second thing is what? It is inversely proportional to the distance of the point O from P. So this is the distance of the point O from P. If it is nearer, intensity is larger. If the distance goes on increases, then the intensity goes on decreases. So that's what, inversely proportional to the distance. And third thing, it varies with obliquity factor. What is obliquity factor? 1 plus cos theta value is called as obliquity factor. Okay. So again, as I said, no, angle goes on changes. So that's what, it depends upon the obliquity factor. And today's class, we had taken only the first point, that is the area of the zone. So that's what, as the zone are in a circular shape, the area of the zone can be calculated by using the formula pi r square. So if you want to calculate the area of the zone, then r value is needed. R is nothing but what? Radius. So first I had calculated a radius here. PM1 is the radius. So already we know how to construct a zone plate. If anybody is having the confusion about the zone plate, then please see my last video. then you can understand how to construct this plate. Understanding? In Fresnel half period zones also I told, and even in a zone plate also I told the same thing. Okay, so now as this is the case, by taking O as a center and A plus lambda by 2, we are drawing a first circle. A plus 2 lambda by 2, another circle. A plus 3 lambda by 2, third circle. Like that, A plus n lambda by 2, nth circle we draw. Okay, so after drawing the circle, now radius of that circle we are finding. Means PM1 value, PM2 value, PM3 value we are going to find. Okay, so that's what that one we will calculate by using a Pythagoras theorem. So already you know it is acting like a right angle triangle. So for a right angle triangle, if you apply the Pythagoras theorem, what we will get? OM1 square is equal to OP square plus PM1 square. But which value is needed? PM1 is needed, radius. So that's what PM1 square is equal to OM1 square minus OP square. What is the OM1 square value? Yeah, already we know A plus lambda by 2 whole square minus what is OP value? A. So A square it will be. Now apply a plus B whole square formula, then the things will get cancelled. We are getting A lambda, and lambda square divided by 4 can be neglected because of a smaller value. So we got R1 square is equal to A lambda. Means what is the R1 value? Square root of A lambda. Okay, so square of the radius is A lambda, and only the radius if you calculate, it is square root of A lambda. So from this, area of the first zone we can calculate. So that's what A1 I'll take. Area means this zone. Okay, first zone. So area of the first zone A1 is equal to pi R1 square. So A1 is equal to pi A lambda, because R1 square value is A lambda here. Okay, so this value we got pi A lambda over. And in the same manner, A2 also you can calculate. So remember, while calculating A2, what we should take? See, A2 means area of the second zone. Which is the area of the second zone? Yeah, this part is the area of the second zone. So how to calculate that one? Whole area minus this area you should make. Then in between that area you can calculate. See, like this. This is the first zone, second zone, third zone, like that. So here point is there. This is M1. This is M2. This is M3 suppose. Then first zone is this is A1. Second zone this one A2. Means only this part. Only this part is the area. So that's what we should make. Whole area you calculate. Whole area you calculate. Whole area how we will calculate? Pi. This is whole area means R2 square. And out of that we should make minus pi R1 square we should make. Okay. So whole area is what? Means like this. A2 minus A1. If you make no, in between that the area you can get. That is the area of the second zone actually. So pi R2 square minus pi R1 square, which is equal to pi. What is the R2 square value? Yeah, 2A lambda minus pi. What is the R1 square value? Just now you calculated. R1 square value is A lambda. So if you substitute pi A lambda. Pi A lambda. So pi 2A lambda minus pi A lambda, which is the value how much you will get? 2 pi A lambda minus pi A lambda. So which is nothing but pi A lambda only will get. This is the area of the second zone. Understanding? Like that if you calculate A3, you will get pi A lambda only. So in the same manner, I had calculated the area of the nth zone with the same matter. So what I got? An is equal to pi A lambda I got. Okay. So from this thing what we concluded, the radius is proportional to the square root of the natural number, but the area of all the zones will be what? Equal. It will be equal. Okay. So here 50% is completed, and in the next video I am going to talk about how it is inversely proportional to the distance, and it varies with obliquity factor. Okay, so how the amplitude actually depends upon these things. So we will see in the what next video. Okay, thank you.